Welcome back to the channel. Today, we're diving deep into one of the most exciting technologies powering modern AI applications, vector databases. Whether you're building recommendation systems, chatbots, or the next breakthrough AI application, understanding vector databases is absolutely crucial. By the end of this video, you'll understand exactly what vector databases are, why they're game changers, and how you can start using them in your own projects. So let's jump right in. Let's start with the basics. A vector database is a specialized database designed to store, index, and query high-dimensional vectors efficiently. But what does that actually mean? Think of traditional databases. They store structured data like names, ages, prices. Vector databases store mathematical representations of data called vectors or embeddings. These vectors capture the semantic meaning of data, whether it's text, images, audio, or any other type of content. For example, the word king might be represented as a vector like 0.2, -0.1, 0.8, 0.4, etc., with hundreds or thousands of dimensions. The magic is that similar concepts have similar vectors. You might be wondering, why can't we just use regular databases? Well, imagine trying to find similar products in an e-commerce database using SQL. How would you query for items that are kind of like a smartphone, but not exactly? This is where vector databases shine. They excel at similarity search, finding data points that are semantically similar, not just exact matches. This is crucial for AI-powered search engines, recommendation systems, content discovery, chatbots and Q&A systems, image and video search. Plus, modern AI models generate vectors with hundreds or thousands of dimensions. Traditional databases simply aren't optimized for this type of high-dimensional data and similarity queries. The process is surprisingly elegant. First, your raw data, text, images, whatever, gets converted into vectors using AI models called embeddings. These could be models like OpenAI's Text Embedding Ada 002 or Google's Universal Sentence Encoder. Next, the vector database creates specialized indexes. Unlike traditional B-tree indexes, vector databases use algorithms like HNSW, IVF, or LSH to organize vectors in high-dimensional space. When you query, you convert your query into a vector using the same embedding model, then the database finds the most similar vectors using distance metrics like cosine similarity or Euclidean distance. Here's what a simple query looks like in Python with a vector database. Let's talk about the math behind the magic. Vector databases use several distance metrics to measure similarity. Cosine similarity measures the angle between vectors, great for text. Euclidean distance, straight line distance in n-dimensional space. Dot product, fast computation, good for normalized vectors. And Manhattan distance, sum of absolute differences. For indexing, there are several key algorithms. HNSW, hierarchical navigable small world, excellent balance of speed and accuracy. IVF, inverted file index, good for very large datasets. LSH, locality-sensitive hashing, great for approximate searches. FAISS, Facebook's library with multiple algorithm options. Each has trade-offs between query speed, accuracy, and memory usage. Now, let's look at how vector databases are architected. At the core, you have the vector storage layer, which handles the actual vector data and metadata. Above that is the indexing layer. This is where the magic happens. It organizes vectors for fast retrieval using the algorithms we just discussed. The query processing layer handles incoming requests, converts them to vectors if needed, and orchestrates the search process. For production systems, most vector databases support distributed architectures with sharding, replication, and load balancing, just like traditional databases, but optimized for vector operations. Let's see vector databases in action. Netflix uses vector databases to power their recommendation engine. They convert your viewing history, preferences, and even the time you watch into vectors, then find similar user profiles to recommend content. Amazon uses them for product search. When you search for comfortable running shoes, it's not just matching keywords, it's understanding the semantic meaning and finding products that match that intent. ChatGPT and similar AI assistants use vector databases for retrieval augmented generation. They store knowledge as vectors and retrieve relevant context for more accurate responses. Here's a simple example of building a document search system using a vector database. So, why are companies adopting vector databases so rapidly? Let me write down the key benefits. First, semantic search capabilities. Instead of exact keyword matching, you get intelligent, context aware search that understands meaning and intent. Second, massive scalability. Vector databases can handle millions or billions of vectors while maintaining fast query performance. Third, real-time updates in queries. You can continuously add new data and get instant results, crucial for dynamic applications. Finally, flexibility. They work with any type of data that can be vectorized: text, images, audio, sensor data, you name it. But it's not all sunshine and rainbows. Vector databases come with their own set of challenges. First, complexity. You need to understand embeddings, choose the right models, tune parameters, and manage the entire pipeline. Second, cost considerations. High-dimensional vectors require significant storage and compute resources, especially at scale. Third, accuracy versus speed trade-offs. Approximate algorithms are fast, but might miss some relevant results. Finding the right balance is crucial. Finally, embedding model changes. If you update your embedding model, you might need to reprocess all of your existing data. Let's survey the landscape. There are several excellent options available. Pinecone is a fully managed cloud service, great for getting started quickly without infrastructure headaches. Weaviate is open source with excellent GraphQL APIs and built-in vectorization capabilities. Chroma focuses on simplicity and developer experience, perfect for prototyping and smaller applications. Milvus offers enterprise features and massive scalability, ideal for large production deployments. Here's how the same operation looks across different platforms. Before we wrap up, let me share some hard-learned best practices. First, choose your embedding model carefully. Consider your data type, domain, and performance requirements. Don't just pick the most popular one. Second, tune your indexing parameters. Start with defaults, then optimize based on your specific query patterns and performance requirements. Third, implement proper monitoring. Track query latency, accuracy metrics, and resource usage to catch issues early. Finally, plan for data versioning and model updates from day one. You'll thank me later when you need to upgrade your embedding model. Looking ahead, vector databases are evolving rapidly. We're seeing improvements in efficiency, new algorithms, and better integration with AI frameworks. Expect to see more multi-modal capabilities, databases that can handle text, images, and audio vectors in the same system with cross-modal search capabilities. Deeper integration with AI ML platforms is also coming, making it easier to build end-to-end AI applications. And don't forget about edge computing. We'll see more lightweight vector databases designed for mobile and IoT devices. And that's a wrap on vector databases. We've covered what they are, why they're important, how they work, and how you can start using them today. If you found this helpful, smash that like button and subscribe for more deep dives into cutting-edge technology. Drop a comment below with your vector database questions or share what you're building. Thanks for watching, and I'll see you in the next video.